Welcome to this question. We're gonna start by first and foremost working a KP question. This KP question, I think it's simple, but it's the same format for every other single question. So we're gonna start with writing the reaction and doing the ice table. This is a decomposition reaction, but for you it doesn't really matter whether you know what the type of reaction is. You just need to know how to fill in the ice table. I normally do it in terms of x. And then we must be noted that we were told that 20% of x was dissociated, 20% of 2 equals 0.4, therefore x equals 0.4, and that means that this would then become 1.6, that becomes 0.4, and that becomes 0.8. And this is what you have to do first and foremost. Then you're gonna find partial pressure of x, partial pressure of y, partial pressure of z. So for x, the partial pressure will be the moles of x, so mole fraction, remember? So moles of x over total moles times total pressure, which is equal to 45.71 megapascal. You can leave it in megapascal. For y, it's 0.4 over 2.8 times 80, which is equal to 11.43 megapascals. So you know if you made a mistake, because this has to be a quarter of the first one, because 0.4 and 1.6 is a quarter. And for that, you're gonna have 0.8 over 2.8 times 80, which is equal to 22. Apologies. 0.86 megapascals. Once you do this, I think the hard bit is done. You write Kp equals, and this will be partial pressure of y times partial pressure of z squared over partial pressure of x, or that is equal to 11.43 times 22.86 squared over 45.71, and this gives a value of 131 megapascals to the power of 2. So Kp will be 131 megapascals to the power of 2. Again, don't think it's a difficult question. Just try these out. I think you should be fine. Okay? If you need anything, just ask.